so we're going to simplify this. So we have 2x to the negative fourth y squared, that's on top of our fraction, divided by 4x to the negative 3 y squared. Now these are properties of exponents. We've got to get these down. We've got to get these down. So we sing our song. When you multiply, now guys, this song only works if you have the same base. When you multiply, you add. When you divide, then you raise a power to a power and you multiply. I need you to pay attention today to the little details. I think some of you ignore the little details. You say, I get that, and then you don't pay attention to the little details. So watch carefully. Now, does that song work with numbers? No, those are not like bases. They're just numbers. So we're going to treat numbers like numbers. So 2 over 4. 2 divided by 4. Now do this carefully. Think about this. 2 divided by 2 becomes 1. 4 divided by 2 becomes 2. Now is my 2 in the bottom or top of my fraction? Bottom. So it has to stay there. Does everybody understand that? Okay. Please ask questions today if you do not understand that. Okay. So 2 has to stay on bottom. Now 1 times all this stuff is just going to be all this stuff, right? Okay. Now when you divide the same base, you subtract your exponents. Very important. Listen to this detail. You must subtract the top from the bottom. And you're going to put it on top to begin with. So we're going to have x to the negative 4 minus the bottom. What's the bottom? Negative 3. Did everybody follow what I just did there? I'm going slow on purpose. Okay. Now let's move on to y's. When you divide the same base, you subtract your exponents. Always the top from the bottom. So we're going to have y to the 2 minus what? 2. Do we have questions? That always goes on top for right now. Now I'm going to draw my line again and simplify this again. 2 must stay on bottom. It was on bottom to begin with. Now we have negative 4 minus negative 3. When you subtract a negative, and only if you subtract a negative, you change the signs, right? So we're actually going to do negative 4 plus positive 3. So once again, negative 4 plus 3. So we have x to the negative 1. Do we have questions? Are you sure? Because you all put question mark on the test, or blank on the test, or I got it completely wrong on the test. Is this making sense? Okay. So let's look at our y's. What's 2 minus 2? 0. Are we all comfortable up to here? Okay, I'm going to continue to simplify. I draw my fraction, put my 2 on bottom. So we have x to the negative 1. We know if we have a negative exponent, we're going to grab it and flip it over a fraction. It makes it a positive exponent. So we're going to grab that and flip it over our fraction. Now, is it negative anymore? No, well, the reason we flipped it was to make it positive. And then any base raised to the 0 power is not equal to 0. Any base raised to the 0 power is equal to 1. Thank you. So that whole thing becomes a 1, not the exponent. I saw many of you do that on the test. You said, oh, it goes to a 1. The 0 doesn't become a 1. The whole thing becomes 1. Does that make sense? So what's left on top? 1. So our final answer in this one will be 1 over 2 times x. X to the first is just x. Do we have any questions on that? Now, a lot of people, if there wasn't anything left on top, there always is a 1 left on top, and they just said, oh, there's nothing left on top, so I'm just going to float 2x to the top. That's not true. There's always technically a 1 on top. So just be really careful. Does that make sense, everybody? Are we okay with that? Okay. So that was our blast from the past problem. Hopefully that will help you with division properties of exponents. You're going to see it again and again. We're going to continue to get more advanced with these. So hopefully that helps. You have no questions on this? All right, let's get to the new stuff. So today, if you want to title your notes 2-1, we're getting into chapter 2 here. The first thing we're going to be doing is determining a degree of a polynomial given a table of values. So we're going to be given x, y points in a table of values, and we're going to look at those data points and decide which degree our polynomial is. Now, before we get started, one thing to remember is that with polynomials, guys, very important, each polynomial has an equation. We see polynomials as an equation all the time. Well, guys, each polynomial that has an equation also has a graph that matches that equation. Does that make sense? We see this all the time. We're given an equation, we know how to graph it. So it's understandable that if you're given an equation, you can do a graph. Well, that goes hand in hand. If there's a graph, there's an equation. Okay? Now also, each equation has a graph which has a table of values. Table of values are just x, y points. So this is a table of values. These are just x, y points. X, y, x, y, x, y, x, y points. Now think about it, guys. This graph has a bunch of x, y points. For example, that's an x, y point, that's an x, y point, that's an x, y point, right here's an x, y point, right here's an x, y point. These are all just x, y points being connected. Do you all understand that? So each table of values has a graph which has an equation. They all go hand in hand. Now understand, these three things are the same exact thing. They're information given differently. So you might be given the information as an equation, or you might be given the information as a graph, or you might be given the information as a table of values. Do you all understand? These are all an apple. This is apple juice, applesauce, and an apple. Does that make sense, everybody? Different forms of an apple, but all an apple. Are we all okay with that? Okay. So I just wanted to get my point across that each function has a graph, which has a table of values. Each table of values has a graph, which has a function. Does that make sense? So now we're going to go ahead. So take brief notes right here of the important things, because we're going to be given a table of values and work backwards. We're going to find the polynomial given the table of values. Okay, so given functions as an x, y point, you can find the polynomial's degree. So we're going to find the degree of the polynomial. Once you know the degree, you're going to use your calculator to find the actual polynomial. So very important. The first thing we're going to be doing is finding the degree given table of values. So first of all, what you're going to do, this is important. You'll want to write this down. Your first step is to take consecutive differences of the y values. So once again, our first step is we're going to take consecutive differences of the y values. Very important. Notice I highlighted y values. We're going to be looking and concentrating on our y values, our output. Now, one thing to note is we're always going to take the difference of the value that comes after the value before it. So we're always going to take differences of the value that comes before the value before it. So we're going to sit and take differences. And once we've taken differences and you see a constant, meaning you take differences and you see all the same number, then you know what degree you will have, depending on how many differences you had to take. Now, yes, I understand these are just words. I'm giving you the steps so that when you get home and you need to refer to your notes, you understand. It's going to make more sense when I show you, but you'll want these steps down. So the second thing is you'll stop when you get a constant. You'll stop taking differences when you get a constant. Now, the number of times you took the differences is the degree. So if you take the differences once and you get a constant, meaning the same number, it's linear. If you take differences once and they're not the same, you'll take differences again. And then if they're the same, it'll be quadratic. The second time you did it, if it was the same, it'd be quadratic. You take differences again, the third differences, and they're the same, it'll be cubic, meaning degree 3. And if you take fourth differences and they're finally the same, then it's going to be quartic. Quartic, 4 quarts in a gallon, right? Everybody, quarts. 4 quarts in a gallon, that's an easy way to remember quartic. Does everybody understand degree 4? So if you take differences 4 times and you finally get the same number, then it's going to be quartic. If you take differences 5 times, it's going to be quintic. Now, I don't know if you remember, you guys are kind of young, but there was a Disney Channel show called Quints, and that was the lady had 5 babies, and so that's an easy way to remember. Quintic means quints, which means 5, so degree 5. So we're going to be taking differences once. If they're not the same, we'll take it again. If they're not the same, we'll take it again. If they're not the same, we'll take it again. Now, let's say you sat and took differences and it never was the same. Then you can't determine the degree. There is a degree, but you can't determine it given the information. So just understand that. Okay, so I'll give you a couple seconds to get this down. It's going to make a lot more sense once we start practicing. But these steps are good to have, because then you can refer back to your notes. And when you get home, you can say, oh yeah, hey, the first thing we do is take consecutive differences of our y values. Okay, I remember doing that, and so on. Here we go. So it says, find the polynomial's degree, and then the polynomial that's generated this data. So given these x, y points, we could sit and go through and plot them and then try to figure it out. That'd be hard. Okay, so we're going to go through and we're going to know now we can find the degree by taking differences of our y values. Very important. Did you all hear that? Of the y values. Now here's the next most important thing, the most common error. You have to start with the value that comes before the value above it. So looking at this one, we're going to start taking differences of our y values. It's very important. You take 2 minus 8. The 2 comes after 8. You have to take the difference of the value that comes before the value above it. So we're going to be doing 2 minus 8 right here. So what's 2 minus 8? 2 minus 8, we have to be so careful. What is it? Speak to me. -6. Awesome. Any questions on what I just did there? Now we're going to take differences again. You always have to take the difference of the value before the next value. So 0, do not make any sign errors. 0 minus 2. -2. Questions? Okay, let's take differences of these two values. 2 minus 0. 2. And then we're going to do 8 minus 2. 6. Did we get the same exact number when we did that? Did we get the same exact number? Is it all the same thing? No. So when we took first differences, it wasn't the same. So it's not linear. Let's take differences again. So now we're going to take differences again. Now you always have to take differences of the value that comes before the value above it. So careful on this one. We're going to be subtracting negatives and all that. We have to be really careful. So right here we're going to do -2 minus -6. So we're doing -2 minus -6. Does everybody see what I did there? Okay, I'm going to erase that so I can keep it nice and pretty. And it is +4. Now, if you didn't know that, you could put it in your calculator, but you have to type it in with your negatives correctly. So -2 minus -6 is 4. Okay, let's take differences again. 2 minus -2. +4. 6 minus 2, 4. Do we get the exact same number the second time we take differences? Yes, so this is degree 2, or quadratic. So this is quadratic. Now, the next part is even easier, guys. Your calculator is going to do all the work. As long as you can figure out if it's quadratic, cubic, linear, whatever, your calculator does the next part, okay? So we know it's quadratic. So now it wants to know the actual polynomial. It wants to know the actual polynomial. So what you're going to do, everybody follow me through this with your calculator. Pull it up, turn it on. Does somebody have these points written down so that they can read it to me? Because my calculator is going to cover it. Do we have these points written down on your notes? Okay, awesome. So pull up your calculator. Follow me through this. You're going to have this memorized. You will see this the rest of the year. You're going to see this on the end of level tests. This should be the easiest problem as long as you know how to do it. So you're going to hit the stat key. So stat, right here, stat. Now we're going to go into edit. So hit enter. Did everybody follow me up to there? Now in list 1, we're going to type in our x values. And in list 2, we're going to type in our y values. So our x values were -2. Hit enter. Now let's say that you had things you needed to delete in here. You actually have to do these ones differently. You'll go up and you have to hit the delete key. So a lot of students are like, oh, clear doesn't work. And you're right. In this list, it doesn't. So look, if I wanted to delete, I would hit delete. Now make sure you don't accidentally scroll up here and hit delete list 1. If you want to accidentally go up there and delete list 1, you're in trouble. You've got to reset your calculator. So don't delete list 1. Does everybody see what I'm saying? All right, so go down in here and you'll type in your x values. Now very carefully in the correct order. So -2, enter. -1, enter. 0, enter. Was it 1, enter, and then 2, enter? Is that how far we got? Okay, is everybody up to there? Now scroll over with your arrows. And you've got to go, we're going to put into list 2 our y values. Now these have to match up. So if you get these wrong, it's still going to give you a polynomial, it'll give you the wrong one. You've got to type it in correctly. What was with -2? 8, so I hit 8, enter. What was with -1? 2, enter. What was with 0? 0. And then what was with 1? And then what was with 2? 8. Okay. Is everybody up to there? Hit enter. Now you're going to hit the stat key again. just hit stat. Now instead of edit, we're going to scroll over with our arrows to calculate. Now you're going to scroll down. We want to do a quadratic regression line. Quadratic, a regression line just means polynomial. So we want to do quadratic. Now if you type in cubic on accident, it's still going to give you an answer. You're going to have the wrong answer. Okay, so you have to type in, we knew it was quadratic for sure because we took differences twice. So we're doing quadratic regression line. So you hit enter, and then it will just pop up like this. You'll hit enter again. Now notice, quadratics have the form ax squared plus bx plus c. It also gives you a is 2, b is 0, c is 0. So now we'll just plug that in. Does everybody see on your calculator? So we know quadratics have the form. We know quadratics have the form. Y is equal to ax squared plus bx plus c. And the nice thing is your calculator told you that. It gave you a was equal to what? So we're going to have 2x squared plus, what would be? 0x plus c, which is 0. So our final answer, this is 0. 0x is 0 plus 0. 0 plus 0, guys, is 0. So we have 2x squared. So y is equal to 2x squared is a polynomial that generated these xy points. Kind of neat, right? Now that wasn't hard. If you don't know how to do it, it's hard. If you're not careful with your differences, it's hard. So guys, it really sucks. I did it just when I was doing the key. I was going way too fast with these differences. Got clear down to this long problem, and I'm like, what the heck? I must have made an error. Something's weird, and I had made an error clear back at the very beginning. So everything was wrong after that. I had to start all over. So go really slow and careful. Okay, I'm going to do problem with you number 1 on the worksheet with you. So if you want to follow me through that, we're going to do it one more time. All right, so looking at this, it says find the polynomial's degree, and then find the polynomial that generated the data. So to find the degree, you focus on your y values, and you take differences, always taking differences of the value that comes before the value above it. So I always like to draw in my little thing like this, and then just go through and take my differences. So very important that you take the difference of the value that comes before the value above it. So do it on your calculator. -7 minus -1. -6 is correct. Now we're going to do -3 minus, so -3 minus -7. 4. And then we're going to do 5 minus -3. 8. Very good. Now we're going to do 11 minus 5. And 9 minus 11. -2. Questions? Okay, let's take differences again. They're not the same when we took it the first time, so it's not linear. So we're going to take differences again. So I like to draw in my little thing here. And then keep going. So carefully, we're going to do 4 minus -6. 10. And then 8 minus 4. 4. 6 minus 8. -2. And then -2 minus 6. -8. Very good. Now our differences were not the same the second time we took it. It's not quadratic. So we'll continue. We'll take differences again. So 4 minus 10. -6. -2 minus 4. -6. -8 minus -2. -6. So did we get the same thing the third time we took differences? So it's degree 3, but I need you to put the right word. It's cubic. It's cubic. Now you'll use your calculator to do the rest. So you'll pull up your calculator. You'll go to stat. You'll hit edit. Hit enter. Then in list 1, we had -3. You can just type over it as well. So -3, hit enter. -2, -1, 0, 1, 2. Ah, what happened? Stat edit. Scroll down. 1. My calculator had a malfunction. -3. -2, -1, 0, 1, and 2. And then in list 2, you type in your y values. Make sure they line up. You will get the wrong thing. If you don't, it will still give you an answer. -1, -7, -3, 5, 11, and 9. Okay, so then you hit stat, the stat key, then over to calculate this time, and then scroll down. This time it's a cubic regression line. It's degree 3, so you hit enter. Now cubics, oh, it has 2 times the cubic. Okay, so stat, calculate. It's so hard to type on these. Cubic regression line. I hit enter. Now it gives you, cubics have the form y is equal to ax cubed plus bx squared plus cx plus d. Then it gives you a is equal to -1, b is equal to -1, c is equal to 8, d is equal to 5. So we'll go ahead and write that. So we have y is equal to, a was -1, so we have -1x cubed, b was -1, so we'll have -1x squared, and then c was 8, so we'll have plus 8x, and then we have plus d, which is 5, so plus 5. Now I'm going to push you, you're in secondary 3, write this correctly, -1x cubed is just -x cubed, minus x squared, -1x squared is just minus x squared, and plus 8x plus 5. This would be our 2 answers, cubic, and there's our polynomial, okay? Now do problems 3 through 4. Do problems 3 through 4. 2, 3, and 4. Thank you. Has everybody got this down? So I can go to my next page. Do problems 2 through 5. Play and watch. Now keep in mind, guys, you could in the future see something like this instead of in a table. So you could see it written as points. So remember, these are just x, y points. But couldn't you put it into a table if you needed to? And then take the differences of the y's? Do you see how I put it into an XY table? That's what I always do. Instead of trying to look at my y's and not mess up and take differences, I just put it in an XY table, write it down differently, and go. Does that make sense, everyone? Keep that in mind. All right. This is something we're going to do number 5 together. Now, this is something you got tested on. You should have it mastered, but you don't. Some of you don't. So we need to talk about it. And it's going to go hand in hand with the next thing we're learning. So look up here. If you didn't understand it in the past, hopefully a second time, third time, fifth time, it's going to make you understand it. So it says, given the zeros, given the x values, the zeros this time, we're asked to find the linear factors. So we're asked to find the linear factors, and then we can find the polynomial generated given these zeros. So we're given the x-intercepts here, the zeros. So we're given x is equal to 0. X is equal to 2, and x is equal to -2. This is not new to us. We've seen this before, right? So guys, we can split it up and say, okay, so x is equal to 0, x is also equal to 2, and x is equal to -2. Now, if we want to know the linear factors, we have to work backwards. We need to get it set equal to 0. Now remember, linear factors are our favorite, because linear factors we can set equal to 0. Well, these have already been set equal to 0, and these are the answers. We're going to work backwards. So let's get everything equal to 0. This one's already done. X is equal to 0. We've got this equal to 0. We need to get this piece equal to 0 using the correct operation. So we're going to subtract 2 from both sides of the equation. Now x minus 2, you can't combine them. They're not like terms. So on the left, that leaves us with x minus 2 is equal to, now look, check your work. Does 2 minus 2 add up to be 0? So a linear factor was x. A linear factor was x minus 2. That must be true if this was our 0. Does everybody see how I'm working backwards? Okay, let's work backwards on this one. What should I do? Add 2 to both sides of the equation. So we have x plus 2 is equal to, check it, make sure it adds up to be 0. So these are our linear factors. X, x minus 2, and x plus 2. Now since our linear factors are all set equal to 0, we can pull them together and multiply them. So I'm going to rewrite this as x times, you have to use parentheses, x minus 2 times x plus 2. We can pull them together and say they all equal 0. Questions? Now we're going to multiply this out. Does everybody see though? This is factored form. Oops. Does everybody see? This is in factored form. But we're working backwards. We want to know the polynomial. Okay? So now we're going to distribute. Now take my suggestion. I'm going to multiply these two things together first, combine like terms, and then last multiply an x. So we have x times x, which is x squared, not 2x squared. I saw so many of you do that on the test. X times x is simply x squared. Now x times 2, positive 2x, so plus 2x. Watch carefully and ask questions. Some of you don't know how to double distribute. Now we're going to look at negative 2 and distribute that through to each term. Negative 2 times x. Negative 2x. Negative 2 times positive 2. Negative 4. Now combine like terms before you multiply an x. So we have x squared, and then what's 2x's minus 2x's? 0. So we have x squared minus 4. Questions up to there? And then we're going to multiply x through. X times x squared is x cubed, and then x times negative 4. Negative 4x. So there's our polynomial. Now if we want to go backwards and get back to our zeros, we could factor this. We wouldn't need to, but we would factor this. We would pull out what's in common, continue to factor, and solve for x. Guess what? We'd end up back here. We'd get these answers. You understand how they go hand in hand? Okay, awesome. So I just did that one with you to really help you see how this next one works. This is new. Ready? Here we go. Well, I'll let you do problem 6 first, actually. I'm hoping that that little pre-game type problem will help you understand what we're doing with the next problem. This is new to us, so everybody paying attention now, right? Everybody paying attention. So I want you all looking at me, not looking at anything but me. So that even means you. Yes, thank you. All right, so we're going to talk about number 7. Now, don't just watch the motions. Try to understand what the problem's asking, or else you're not going to get it when you see it in the future. So everybody listen to me, watching carefully. So it says, given, so we're going to be given a linear factor, guys. We're going to be given a linear factor, and we're going to ask to determine if it truly is a linear factor of this polynomial. So given x minus 2, does everybody see how x minus 2 is a linear factor? Is it a linear factor of this polynomial? P of x is equal to x cubed plus 2x squared minus 6x minus 4. Couldn't we take this piece and factor it and then look to see if that became a linear factor? Is that going to take us a long time? Probably. If we were going to factor this one though, how would we factor it? By what method? By grouping. You knew that because we have 1, 2, 3, 4 terms, right? So we could factor this by grouping and then see, once we were done, was that a linear factor? There's an easier way though. There's an easier way. Are you ready to learn it? Okay, so we know, let's pretend like we say yes. Let's see. This is, let's pretend like it's a linear factor we know for sure. So we know if it's a linear factor, we can set it equal to 0. Is that true? Does that make sense? If it's a linear factor, we can set it equal to 0 and solve for x. So let's do that. Let's pretend this is for sure a linear factor. Let's set it equal to 0 and solve for x. So what would I do? Add 2 to both sides. So we would get x is equal to 2. Okay, so everybody listen carefully. If this is a linear factor, then this would be a root. Now, keep in mind, before we can do any of that, we would have had to take our polynomial and set it equal to 0, right? We have to make sure it's in standard form and set equal to 0. Are we all okay with that? Now, if this was a root, guess what would happen? When we plug it back into the original problem, if that's truly a 0, when you plug it back into the original problem, it better be 0. If not, that wasn't a root. So if we plug that back into the original problem, it better come out to be 0. Otherwise, it was not truly a root. So let's plug it in very carefully. So we're plugging in 2 for x. So we're going to have 2 cubed plus 2 times 2 squared. Does everybody see that I'm plugging in 2? Minus 6 times 2 minus 4. That better be equal to 0. So let's check and see if that's true. So 2 cubed is 8. Then we have to do, now very important, you must do 2 squared first before you multiply in 2. If you multiply 2 in and then raise it to the second power, you were saying that this piece was also raised to the second power, which isn't true. So we're going to do 2 times 2 squared is 4. So I'm showing all my work. Now right here we have negative 6 times 2, which is negative 12. And then we have minus 4. So I'm just simplifying this. So we have 8 plus 8. 2 times 4 is 8. And then minus 12 minus 4 is equal to 0. Let's see if we're going to get a true statement. What's 8 plus 8? 16. So we have 16 minus 12, which is 4. 16 minus 12 is 4. So we have 4 minus 4. 0. So we get 0 is equal to 0. So was x equal to 2 truly a root? Yes, that became a true statement. So now guess what? From now on, you can always check your answers by plugging them back in. So now if this was a root, then this was truly a factor. Because to get the root, we had to have that linear factor. So in this problem, we would say yes. And you would have to show the work. Does that make sense? So if you're given a linear factor, find the root. The root is equal to 0, so when you plug it back in, it better equal 0. Does that make sense, everyone? Okay. One more, and I'm going to let you work. Okay, so it says, determine if x plus 2, this one's not on your worksheet, but I need you to watch, because you're given different things here. So it says, determine if x plus 2 is a factor of this polynomial, x cubed plus 4x squared plus x minus 6. Also, determine if x is equal to 3 is a root. So we're going to check 2 different things here. Over here, let's check if x plus 2 is a factor. So if x plus 2 is a factor, then a linear factor, then we know linear factors can be set equal to 0 as long as the polynomial is set equal to 0. And then we can find the root. So we would subtract 2, subtract 2. So we would get x is equal to negative 2. Well, if this is a linear factor, then this root, when you plug it back into the original problem, better be 0. So if I plug it in, I'll have negative 2 cubed plus 4 times negative 2 squared plus negative 2 minus 6 is equal to 0. Do you see that I'm just plugging it in? Now let's see. What's negative 2 cubed? Negative 8. And then we have plus 4 times negative 2 squared is positive 4, right? And then we have minus 2 minus 6. So if we have negative 8 plus 16 minus 2 minus 6, do that on your calculator. That better be equal to 0. Somebody tell me really quick if that is equal to 0. Is it equal to 0? Negative 8 plus 16 is what? Guys, negative 8 plus 16, you should still be with me. You shouldn't be working on the worksheet. It is equal to 0? Okay, so you just did it and you say 0 is equal to 0. Very good. So we know that x plus 2 is a factor. Now this part's different. Also determine if x is equal to 3 is a root. Well, this time, do we have to, we're given the root, so don't we just have to plug it back in? See if it equals 0. Okay, good. So we would just plug this one in. So 3 cubed plus 4 times 3 squared plus 3 minus 6. That better be equal to 0, otherwise that's not a root. So we would have 3 cubed is 27, and then we have plus 4 times 3 squared is 9, and then plus 3 minus 6. That better be equal to 0. So we have 27 plus 3 minus 6 is equal to 0. So let's check it. plus 36 plus 3 minus 6. So you said 60 is equal to 0. Is that true? No. So this is not a root. Thus, x minus 3 is not a factor, right? Thus, x minus 3 must not be a factor, right? Because if I wanted to know that linear factor, I would subtract 3, and we would get x minus 3. So this is not a linear factor either.
So then you see it's not question.
Pretty much, but I will not mark it right if you just guess yes or no wrong. So I need to see all the work. Does that make sense on how you check both of those? So this one we just plugged back in. It wasn't, so it's not a root. And I just did a little aside and said, so thus x minus 3 is not a linear factor. Does that make sense, everybody? Okay. Now finish the worksheets. Do not skip problems with distance and average rate of change. Those are review problems. I will be very hard on you if you skip those problems when you hand that in. So you're going to do those problems. We've learned distance and average rate of change. If you need help on that, come get help during cat time. Do not skip it, and I will see if you just BS'd it. Watch videos or come get help. We need to remember the old stuff we're learning. Okay, so if you need help on that, don't just skip it, come get help.